Hi everyone, welcome to goclasses. In the last lecture, we have seen the successive combining method. So this method we have seen in the last lecture, the successive combining method to check for lossless decomposition. So this method we have seen, and I told you that this method is only one way. This is a one-way method. What it means that if this method gives you answer lossless, so this successive combining method, this method, if this tells you that answer is lossless, then answer will be lossless. But if this method tells you answer is lossy, but if this method, this successive combining method, if this method tells you that answer is lossy, then remember answer may or may not be lossy. So that is the problem with this successive combining method. So this successive combining method, first of all, this is one way. Okay, so if this gives you answer lossy, then you cannot be sure whether your answer is lossy or lossless. So first of all, this is one way. Also, you can notice this will take a lot of time when you have four or more sub relations. So if you have four or more, four, five, six, these many sub relations, if they give you, then this method, this successive combining method will take a lot of time because you don't know which two to combine. You don't know in which way you should combine because you will try to combine two at a time. You will take two sub relation, you will try to combine them in a lossless manner. So you will try to combine two sub relations at a time in a lossless manner, and you will keep going on, but you don't know which two sub relations you should take. Okay, so this method, this successive combining method, this will take a lot of time, and this is one way only. So that is the problem with this method. So don't apply this method when in the exam they give you four or more sub relations. So in the exam, if they give you four or more sub relations, then always apply the chase algorithm that we will see in the next lecture. But in this lecture, I want to give you one example where this successive combining method will fail. So this example you notice. Okay, on this example we will see that for this example successive combining method will give you wrong answer. So remember, for this example, so what I can say, that for this decomposition, for this for this decomposition, what I can say, for this decomposition, the successive combining method, this successive, okay, combining method, this successive combining method will give wrong answer. Okay, will give wrong answer, I can say. Wrong answer means the successive combining method will give the answer lossy, but the answer is actually lossless. This decomposition is actually lossless. We will see in the next lecture using chase algorithm. So using chase algorithm, we will prove that this is actually lossless. But this successive combining method, this will give the answer lossy. Let us see why this will give the answer lossy. Let us check it out. Okay, so you can notice this is a relation that is given to you, a b c d e, five attributes are there, and set of functional dependencies is also given, and the decomposition is also given. In this decomposition we have five sub relations, r1 to r5. So these five sub relations we have. Okay, now first of all, okay, let's see whether this successive combining method, what it will give you. So before that, let me just write down. Okay, so you can notice a can, what is the transitive closure of a? So a can determine a, c can determine d. So you can notice the transitive closure of a is a c d, nothing else we can get. So what is the transitive closure of b? That is also b c d. And what is the transitive closure of c? That is c d. And what is the transitive closure of de? The transitive closure of de is dec. And you can notice ce can determine a, and a can determine, okay, I can say a can determine cd. So okay, so a can determine cd. So this is what we have here. Okay, so these now similarly you can notice what is ce closure. So that will be cea. A can determine acd. Okay, that can determine acd. Okay, so this is the idea. Now you can notice these are the closures, because these transitive closures will help us in this question, because we are applying the successive combining method. Now in the successive combining method, let us see which two relations you will combine. So let us check it out. Okay, so first, okay, there are many possibilities. Maybe you can combine these two, maybe you can combine these two, maybe you can combine this and this, maybe you can combine these two. So basically, okay, which two relations you will check first. Okay, so first let's eliminate some possibilities. Let's eliminate some possibilities. Can you start with r4? Let us see, can this r4, okay, can this r4 we can combine with something else? Let us check it out. Okay, so basically this possibility, can we combine 4 comma 1? So basically r4 comma r1, can we combine them? Okay, r4 comma 1, Can we combine can we combine them? So in this and in this, you can notice the common set of attribute is D. This is the common set of attribute, and you can notice D can determine. So here I can say what D can determine. D can only determine D, nothing else. So you can notice the common set of attribute in this relation and in this relation is D, and D is not a super key in both of them. So this is not possible. So you can notice this R14, this is not possible. We cannot combine R1 comma R4 in a lossless manner, correct? Because you can notice in this R1 comma R4 the common set of attribute is D, and this D is not a super key in R1, this D is not a super key in R4. So that is the reason we cannot combine. I can say we cannot combine this R4 comma R1. Okay, so this R4 comma R1 we cannot combine. So finally I can say this we cannot combine. Can we combine R4 comma 2? Can I combine this R4 with R2? Let us see this. Okay, so here again you can notice there is no common attribute. Because there is no common attribute, so again we cannot combine them. Okay, so this R4 comma 2 also we cannot combine. Can I combine R4 comma 3? This and this. Okay, in these two sub relations you can notice that what I can say, that the common attribute, the set of common attribute is E, and what E can determine. Okay, so let us check here what E can determine. Here E can only determine E, nothing else. So from this set of functional dependency you can check E cannot determine anything else. So we cannot combine this R43. Okay, so this R43 also we cannot combine because E is not a super key in R3. E is not a super key in R4. So that is the reason we cannot do this. Now let us see, can we combine R4, 5? These two can be combined. So what is the set of what is the set of common attributes? So you can notice the set of common attribute is E. Again, you can notice that E is not a super key in R4, R5. So we cannot combine R4, R5. So you can notice that this R4, we cannot combine this R4 with any of them. So this R4 we cannot combine with any of them. Now let us see. Okay. Now, okay. So this is this we have seen. Now let us see. Can we combine R3 with something? Can we combine R3 with R1? Can we combine this R3 with R1? Can we do this? There is no common attribute, so we cannot do this. And you can notice, can we combine R3 too? Can I combine this R3 with R2? So let us check it out. The set of common attribute is B, and you can notice what is the closure of B. B can determine CD, BCD, but B cannot determine E, B cannot determine A. So basically the point is very simple, that the common set of attributes is B, but B cannot determine anything. B is not a super key in R2, B is not a super key in R3, so we cannot combine them. Now, can we combine R3, 5? Can we combine R3, 5? So let us check it out. Again, the set of common attribute is E, and you can notice E can only determine E. So E is not a super key in R3, E is not a super key in R5, so we cannot combine this also. So this R3 also we cannot combine with anything else. Okay. So finally, what are the possibilities that we have? So this R3 we cannot combine with anything else. R4 we cannot combine with anything else. Okay. So finally, these are the possibilities. Can I combine R2, 5? Can I combine this R2, R5? Can I combine these two? Again, you can notice the set of common attributes is E. This is the set of common attribute, and you can notice, the set of common attribute is A, and this A does not determine, this A cannot determine B, E. You can notice A determines ACD, so A cannot determine this attribute A cannot determine B, E. So that is the reason we cannot combine them also. So what are the possibilities? So finally, okay, these things we cannot do. And now finally you can notice that we can combine R12 or we can combine R15. So either we can start with R12. Finally, I can say only two choices. Okay, two choices you have. Only two choices to start. Okay, so if you want to start, so only two choices you have to start with. Okay, what you can do, either you combine R1 with 2 or you combine R1 with 5. So this is the choice we have and this is the choice we have. No other choice we have. So either we can combine them, either we can combine them. Now let us check whether if we combine R12, then what will happen. So let me start with R12. Okay, so let us assume you are combining R12. Can you combine them? This is R1, this is R2, and what is the common set of attribute? The common set of attribute is A, and you can notice A can determine D. So this A is a super key in R1. So I can say yes, we can combine R12. So finally I will get A, B, D. So this R12 I got. Okay, so remember now this is gone, and now I have R12. And we already know that this I cannot combine with this. So R3 R4 we cannot combine, this we already know. R3 R5, so these we cannot combine, this we already know that these we cannot combine. R5 R4 comma R, okay, so these we cannot combine together. Okay, so basically, okay, now you can notice finally what I can do. Okay, so let me check, can I combine this with this, can I combine this with this? Okay, let me check, can I combine this R12 with R3? So there is no common attribute, you can notice. So we cannot combine this R12 with R3. So you can notice this R13 with R2, this we cannot do. Okay, next, can I combine this R12 with R4? So okay, before that let me check, can I combine this R12 with R5? Can I combine R12 with R5? Okay, so can I do this R12 with R5? So the common set of attribute is A, and you can notice A cannot determine, A cannot determine ABD, A cannot determine AE, because we already know A can determine ACD. A can determine only ACD. So you can notice that A is not a super key. This attribute, this common attribute A, okay, between this and between this, the common set of attribute is A, which is not a super key in R12. It is not a super key in R5. So we cannot combine this. So the only choice, you can notice after this, the only choice that we have, this is the only choice that we have. What we have to do, we have to combine this R12 with R4. Can we combine them? First of all, you check it. Okay, so this is CDE, this is ABD. So the common set of attribute, what is that? So common set of attribute is D. So D is the common set of attribute, and you can notice what D can determine. So let me check it out. So what D can determine? D can determine only D. D can determine only D. D cannot determine anything else. So finally, I can say that you can notice. Okay, the only choice we have is, so can we combine them? R12. Actually, this also we cannot do. You can very easily see that this R12 we cannot combine with R4 also. So this R12, this R12 we cannot combine with R3. This R12 we, because you can notice, okay, B, the common attribute is B, and B cannot determine BCD. So B cannot determine, yes, correct. So you can notice this R1, this R12, okay, here I can say this is R12. This R12 I cannot combine with R3, this R12 I cannot combine with R5, and this R12 I cannot combine with R4 also. This also we cannot do, because the common set of attribute is D, and D is not a super key in both of them. So that is the reason I can say that this choice is gone. Okay, I can say this choice is actually gone. So this choice we have checked, and this choice will not work. So actually we have done this checking. So this choice will actually not work. So this choice will actually not work. We have done this. Okay, so this choice will not give you final. Okay, now this choice. Okay, let's start with R15. So can we start with R15? Now let us check it out. Okay, so if we start with R15, then we will get ADE. So this R15, now this R1 is gone, R5 is gone. So this is your R15. Remember, these two I cannot combine, we have already seen. These two I cannot combine, we have already seen. This and this we cannot combine, we have already seen. So finally what we have to do, can I combine this with this? Now this is what we have to check. Can I combine this, can I combine this R15? This is the question. Can I combine R15 with R2? So the common set of attribute is A, and you can notice what A can determine. A can determine ACD. A can determine ACD. So A cannot determine B, A cannot determine E. So this also we cannot combine. Now let us check it out. Can I combine R15 with, okay, so this I cannot combine with A, and can I combine with R3? Can I combine with R3? So the common set of attribute is E only, and you can notice E cannot determine anything. E can only determine any E. So that is the reason we cannot combine them also. So this also we cannot combine. The only possibility is we can combine R15 with the R4. So basically this R15, the only possibility is we can combine with R4. So what is the common set of attributes? So here CDE, this is ADE. So the common set of attributes is DE, and you can notice what DE can determine. DE can determine DECA. DE can determine DECA. So this DE, this can determine DECA. So yes, this is a super key in R5. So you can notice this is the super key. Actually, this is a super key in R15. So we can combine this. So what we can do, this R4 and R15, these we can combine. Okay, so this R4 R15, so this is what we are going to combine. Okay, so finally this R4 is gone and this R15 is also gone, but we are going to combine. Okay, so this is what we are going to do. So okay, now a this is what we are going to do. R145. Okay, so this is what we are going to do, so we can combine them. Okay, now you can notice, now we cannot combine these two, R2 R3 we cannot combine. Now let us check it out. Can I combine this R145, this R145? Okay, this I can combine with R2 or not? So the common set of attribute is only A cannot determine E, A cannot determine B, so I cannot combine them because the common set of attribute is A, and this is not a super key in both of them, so I cannot do this. Can I combine R145, this relation? Can I combine with R3? Can I combine with R3? So let us check it out. Okay, so the common set of attribute is actually E. This is the common set of attribute, and this E is not a key. This E is not a super key in both of them, so again we cannot combine this. So you can notice that now we are stuck. So finally we have seen that all the ways, whatever you do. Okay, so we have exhausted all the possibilities. So remember, now we have exhausted all the possibilities. We have seen all the possibilities. We have seen all the possibilities. All the possibilities. We have seen all the possibilities of combining. We have seen all the possibilities of combining two subrelations at a time. Two subrelations at a time. Okay, two subrelations at a time in a lossless manner. In a lossless manner. So we have seen all the possibilities of combining two subrelations at a time in a lossless manner. Okay, no such possibility exists. I can say no such possibility exists. No such possibility exist. Okay, so this is the point. So no such possibility exists means I can say that by taking two relation at a time. Okay, I am taking two at a time, two at a time. Okay, so I can say here, I can say finally what this successive, I can say that this successive combining method, what this gives the answer. So here the successive combining method, so this successive combining method gives the answer lossy. So this successive combining method gives answer. Method is giving answer. Method is giving answer lossy. Is giving answer as lossy. But actually it is lossless. But this decomposition is actually lossless. Okay, but this decomposition, remember this decomposition is actually lossless. We will prove it. So this decomposition is actually lossless. This decomposition is actually lossless. We will prove it by, okay, we will see that it is lossless. We will see using chess algorithm. Okay, so in the next class we will study the chess algorithm, and from that, using that algorithm, we will see that this decomposition is actually lossless. But this method, this successive combining method, this is giving the answer lossy. So that is the reason this example, you can notice this example I have taken, so that you can see that this successive combining method is wrong. This successive combining method is only one way. If this method tells you that answer is lossless, then answer will be lossless. But if this method tells you answer is lossy, then answer may or may not be lossless. Okay, so this is the point, remember. So finally, this is my suggestion to you, that okay, this is the final conclusion. Remember, this is the final conclusion. Let me tell you the final conclusion. And let me tell you, once you see this, once you practice this chess algorithm will take very less time. You can notice this successive combining method is taking a lot of time. We don't know where to start, we don't know which to combine first. We don't know, okay, like we don't know whether to combine these, whether to combine these. Okay, we don't know whether to combine these, so we don't know what to do. You can notice, so this successive combining method is taking a lot of time. So okay, so that is the problem, you can notice. So this is the final conclusion, that this successive combining method. Okay, so this successive combining method, this successive combining method, first of all, this is wrong. I can say this successive combining method, this is only one way. This is only one way, so not reliable. So this successive combining method is not reliable, first of all. Okay, because this is only one way. Okay, because if this method says that answer is lossless, then answer will be lossless. But if this method says answer is lossy, then answer may or may not be lossless. So this is not reliable. Also, this will take a lot of time. Also, this method is actually a lot of time consuming. So this method is actually time consuming. Okay, so this method is actually time consuming. And another, you can notice this chase algorithm. This chase algorithm actually, this chess algorithm is very nice. I can say this chess algorithm, this is a correct, first of all, this is a correct method. First of all, this is a correct method to check for lossless, to check for lossless or lossy decomposition, lossless or lossy decomposition. So first of all, this is a correct method. Second, you can notice that this is time efficient method. This is a time efficient. This is time efficient method when you have, this is time efficient method when you have non-binary decomposition. For non-binary decomposition, for non-binary decomposition, this is actually time efficient method. We will see, this will take a very small time. Actually, this will not take much time. This is a very simple method. And okay, so this is actually time efficient method for non-binary decomposition. So if you have non-binary decomposition, means if you are decomposing into more than two sub relations, if you are getting 3 4 5 6, these many sub relations if you are getting, then this chase algorithm you can apply. This is the correct method for checking lossless or lossy decomposition, and this is actually time efficient. And this is two way. If this says lossless, then answer is lossless. If this says lossy, then answer is lossy. And this method we will see in the next lecture. Okay, thank you everyone.